Miller Rhodes, and today we're going to be talking about Git, its advantages, and the mechanics of use with PowerBuilder 2019. So what are we going to talk about today? First, I'll give you a little background on Git. Then I want to do a comparison of Git and traditional MSS CCI-based source control. Next, we'll do a demo where I'll show you how to create and populate a repository with your PowerBuilder code using a particular repository that I've picked. After that, we'll talk about creating branches in PowerBuilder 2019. Now, this is before release 3. The whole process actually has to be done outside of PowerBuilder, and it's quite cumbersome. After that, we'll do another demo where I'll create and use a branch within a repository using PowerBuilder 2019 Release 3. And you'll be able to see how powerful and simple that process is. Finally, real quick, we'll do a case study where a customer of mine pushed some code that they did not intend to push, or it wasn't finalized into their repository, and they needed to back that out. And so I will walk you through what they did to remedy that situation. Now a little bit about me. Once again, my name is Miller Rhodes. I work with Intertech Consulting. I've been working with PowerBuilder since 1992. Version 2.0 at that time, 2.0 beta. And I'm currently working with 2019 Release 3, not on a project, but working with 2019 Release 2 on a project. I have worked with Power Server since 2010. I've built C# web services using SnapDevelop. I've been working with SQL Server and Oracle for the past 20 plus years. And I've worked with Git for the past 2+ years. Some of the recent projects that I've done, all of which have used Git as their source control. The first was a migration of a large-scale PFC application to Power Server. The next one was a migration of a 200+ window 3-tier PowerBuilder application from a proprietary C middle tier to C# using SnapDevelop. And then finally, we migrated a PowerBuilder version 3 application that had been around for 20+ years. We migrated it up to PowerBuilder 2019 Release 1, and we retrofitted that application to use PowerBuilder PFC and changed the whole look of it to a more modern look and feel. So let's talk about Intertech, the company I work for. Intertech is the oldest and largest consulting firm specializing in PowerBuilder technologies in North America. Intertech was the first company in North America independently certified by Sybase and Appeon to sell and support the Appeon Power Server product. Intertech has been a Microsoft partner since 1995. They were a PowerSoft partner from 1995 to 1997. And then, of course, PowerSoft went to Sybase, or rather the PowerBuilder product was bought by Sybase. And so they were a Sybase partner from 1997 to 2013. And then SAP, of course, acquired Sybase, and so they've been an SAP partner since 2012. All the way through present day. And they are an Appeon consulting partner, and they've been that for a number of years, I think all the way back to 2010, maybe before that, even before obviously Appeon had bought PowerBuilder. Intertech is not just a body shop. Intertech is a value-added proposition where we do many things. We help you with architecture, and we have expertise in that area. We do consulting. and programming. We provide PowerBuilder and Appeon-based education and Microsoft-based education, all sorts of things. And we do project management. Okay, so now let's do a little background on Git. Git was created by Linus Torvalds in 2005 for development of the Linux kernel. Then a guy named Junio Amano has been the core maintainer of Git, which is open source. And every Git directory on every computer is a full-fledged repository with complete history and full version tracking abilities. That are independent of network access or a central server. Git is a free and open source distributed version control system, and we'll talk more about that. It handles everything from small to exceptionally large projects. Git can be used to track changes in any set of files. Its goals include speed, data integrity, and support for distributed non-linear workflows. Now let's do a comparison of Git and traditional MSS CCI-based source control systems. And by the way, MSS CCI means Microsoft Source Code Control Interface, which is basically an ODBC for source control systems, most of which are centralized. Now, the source systems that many of us use are centralized. Team Foundation Server, or TFS, Visual Source Safe, and Subversion, which is a source control system that's facilitated within PowerBuilder, of course. In centralized source control, there is one single repository on the server and a client. The server is the master repository, which contains all the versions of the code. Git is a distributed source control system. Every single developer or client has their own server. Each has a copy of the entire history or version of the code and all its branches in their local server or machine. Every client or user can work locally and disconnected, which is more convenient than centralized source control, and that's why it's called distributed. So let's get into this in a little bit more detail. Centralized versus distributed. Now, in centralized source control systems, the developer checks out code which locks any objects that are being worked on. Then when the developer's done, the developer checks in their modified code, and that's where it goes. Distributed, developers clone the entire repository to their machines, including all the history. Redundancy exists in case the server dies. So you've got that backup, your local repository is there, and so if you lose access to the server, or something happens to it, then you've got all your code, and you've got basically a snapshot. Now, you commit changes to your local repository without having to talk to the server. The developer can work on several items using branching, commit those, and only push those committed changes to the server when fully tested. And let's talk about branching. What is it? In a centralized source control system, the way you would do branching is you would take a copy of your code and put in another directory, work on things there until they're fully baked, and then you could copy that completed work back into your directory that's under source control and then check it in. With a distributed source control system, the branching is more logical. You don't have to create another directory. You can create a branch, which is a separate area for development, and then you have what's called a master branch, which is where your pristine production code usually lies. And so you can work on a development branch or multiple development branches. And then when that code is finalized, then you can commit that code and push it. And then ultimately, when you've done plenty of testing, then you can merge that into your primary or master branch and then deploy it to your customer. So using Git, Okay, let's get into this in a little bit more detail. There are a variety of Git repositories available. There's Bitbucket, GitHub, and Azure Dev Ops, and GitLab. So many flavors of Git. Many files cannot be managed in PowerBuilder. So a lot of the Git source control management within PowerBuilder can't be done for objects that are not PowerBuilder objects. PowerBuilder is only aware of pibbles, objects, targets, and the workspace, and other PowerBuilder objects. Graphics, INI files, and other project files require a third-party tool. Tortoise Git is one of my favorites. Also, source control statuses can only be seen from the system tree. They cannot be seen in the library painter. So be aware of that. Usually when you've modified an object, you'll see a little check mark next to it. And then when objects have been committed or they're unmodified, there's a little dot next to it. There are many GUI clients for Git. Many of them are free. There's Tortoise Git, which I mentioned before, GitHub Desktop, and SourceTree. So having a GUI client to manage your Git repository or your interactions with it is just more user-friendly. Or you can just use the command line, which a lot of people like to do. And there's some more complicated manipulations where a person might use the command line. So that's always a good thing. And in order to version your non-PowerBuilder objects and be able to add those in to your repository and replace them, add new ones, you're going to need that third-party tool. Because once again, PowerBuilder is not going to be aware of any of those files or objects that are outside of PowerBuilder. So now we're going to get to our demo. We're going to create a repository. And actually, I've already created it, but we're going to populate it using Azure Dev Ops, which is a Microsoft tool, repository, and it's one of my favorite to use. And just to give you a little information up front, when creating a repository, it's recommended that you give the Git repository a meaningful name. Probably not a good idea to name it exactly after your workspace or target name, but something meaningful to your project or the application that you're working with. Another thing that I wanted to mention is I've included some steps to accomplish what I'm doing in the demo in some other slides that I won't be showing you today, but those will be available after this presentation so that you'll have a step-by-step that you can follow in order to do this yourself. Now we'll get to the demo. Okay, so here I have a virtualized environment. And what I've done is I have created a repository called Elevate Rec. Okay, and what we're going to do first is we're going to go over here to clone, and over here what has been created is what we call our Git URL, and this is a pointer to your repository. It's what PowerBuilder will use to know where your repository up on the server is located, so that it can go and pull the code down when you need to do that. And, it's basically a pointer that can be used to interact with your repository. So what I'm going to do is I'm going to copy this URL. And then I've already done a couple of things in the command line here. So let's go to the command line. I've created a folder called Elevate Video. And so that's going to be where we're going to put our code that we're going to push up to the repository when we're loading it. And so the first thing I want to do is, once I'm in there, I want to do a git clone, and then I'll put in the URL, say OK, and then we'll wait. And now that we've done that, what has happened, let me go show you, is it has created a folder. If I go into Elevate Video, a folder called Elevate Rec. Okay, and so what I'll do is I'll open that folder, and here's a couple of files that it's created that we'll need to manage our repository. And what I have to do before I go any further is I need to go get my code that I want to put in there. So here's my PowerBuilder code, and I think it works best if it's in its own folders. You can leave your workspace file and maybe some other files outside of those folders, but your pibbles should go in here. So what I'm going to do is I'll copy this, and then let's go over here and we'll paste it in here. Okay, now what we can do is we'll go back to the command line, and then before we do anything, we need to do a CD, and we need to go to our elevate rec folder. Okay, and then the first command that we're going to do is going to be a git add star, which is going to be the first step in moving our code into the repository. So we do that and wait a second. Okay, and then now what I've done is, so that I don't have to type, the next thing we're going to do is we're going to commit the code. So let me go and grab this here, and I'm going to come back over to the command line here. Fortunately, with the command line, you can paste stuff in. So let's do that, and we'll say okay. Okay, and see, now you can see there's all of our objects in here that are going up. And let me make this a little bit bigger. And you can see all of our pibbles and some some source files went up to the repository. And the next thing we're going to do is we're going to do a git push, which is what's actually going to push it up to the repository. The git commit actually just updated our local repository, but now the git push will push it up to the server. And that shouldn't take too long. Okay, and now what we can do is we can go back to our repository, and I'm going to refresh the screen. And look, now you can see all of our files are in here. Okay, so now what I'm going to do is give me a second. Okay, so the next thing we're going to do is now we're going to open up the PowerBuilder IDE. And you have to make sure there are no workspaces open. And let's go back to our repository here. And let me go back to where we can do the git clone. Okay, so we're going to go over here, and we're going to grab our URL again because we're going to need it for PowerBuilder. And then we need to generate a set of Git credentials. And one thing I want to mention to you is that these are admin functions. This is what a person would do who's setting up your repository. This is not something that developers will need to do. Later on, the developers will do a subset of this where they'll just pull the code down and then can begin working with it. So I'm going to generate a set of Git credentials. And you can see my username and, a very complex password here. So let me just make sure I've grabbed that. And I'll need this password, which I've actually already got another one that I've set up, but you would need this in order to connect to the repository, security and all. So let's go back to PowerBuilder. And what you do in PowerBuilder is you right-click on where the workspace would be, and you do what's called a connect to workspace. And you can see Subversion is one of the supported source control systems here, and we just go to Git. And then since I've done some things here already, what I want to do is paste my URL in here. Okay, and you can see at the end of this URL is the name of our repository, elevate rec. And then we have to put in the name of our workspace file, and then there's my name. And then I've already put in my password here, and let's just test the connection. Okay, so test connection succeeded. And then what we need is we need a directory to put our code into locally so that we'll ultimately be able to start working with it. So I'll just open that, and then let's go to the, we could have a directory already created, but what I'm going to do is go to my C drive, and I'm just going to create a new folder. And so we'll call this Elevate Test. We'll just call it that. Okay, so let's get off of there. We've created our Elevate Test. Make sure it's selected. Say OK. Okay, and then I don't think these are necessarily required, but just my name and email. And then this is something that's new in release 3. Refresh all pibbles. So when you pull the code down, what happens is it will pull down whatever is current in before any updates had been made, or the last time that updates were made to the pibbles. So you'll get that code, but what you won't get is any changes that other developers have made. But in this case, since we're seeding this up front, the refresh probably won't do much, but what the refresh does is it pulls changes into the pibbles, and that's an extra step that it used to be you had to do, but now you can just check this box and it does it all for you. So what I'm going to do is, since this may, okay, well, I was thinking in case it might take a while, I might pause, but that completed. So here's our code. We can see our stuff. Now, if you notice, there's little pluses next to the code here. So this is not in source control yet. We just got the code, but we got a few more things we have to do. So now, just to be safe, what I want to do is I have to right-click on the workspace, and then you can see it's already telling us in release 3 that we're on what's called the master branch. Okay, and I'll talk about that later. And then you can see Git create branch and switch branch, which we'll talk about later on. But what I'm going to do now is I'm going to do a refresh. And you can see, since there haven't been any changes made, the code was just as is. The refresh didn't really have to do anything here, because what we uploaded to the repository is what it is, and nobody's made any changes since we did that. So now what we're going to do is we have to commit our code to our local repository. So I right-click here on the workspace, do a git commit, and so now it's going through all of our objects, and we're basically beginning to create that connection between our code that's on our computer and the repository that's up on the server, and also that connection with our local repository as well. Okay, so here we have all of our objects, all checked and ready to go. And what I'm going to do is I'm going to put a comment here, and I'm going to say adding WS objects. So what WS objects is it is a folder that is actually going to contain all of our source, all of the SRCs, SRWs. That's what actually gets maintained in Git. With Git, the pibble is an empty container, but it has to be there. What's actually going to be maintained in Git is the actual source files for your PowerBuilder code. So if we go back here real quick, I'll show you. Let me close that. You can see all these folders, but you can see there's no WS objects folder, and that's going to be something that'll be added when we do the next step. So let's go back to PowerBuilder, and then let's say OK. And now what we have to do is let's wait for it to do that, and you have to be sure that this is finished. It's thinking right now, but what we're going to do is we're going to wait, and it'll basically let us know when it's done. You would almost think that it was done, but we're just going to wait for a second. And so let me just close this real quick so that we don't have to wait. Give me a second. Okay, so let's go back in here. Okay, so now that our git commit has completed, you can see that it was going through all the files, almost like a regen. And, it goes through and is committing all these files. The next thing we have to do to finalize this is we're going to right click on the workspace again and do a git push. And that's what's actually going to push it up to the server. And see, that actually goes pretty quick. So let's go back to our repository again, and I'm going to refresh the screen. And then you can see here's our WS objects here. And it says just now, and then if we go look at the history, you can see our comment in here, add WS objects. Isn't that cool? Okay, so now for the next step, give me a second. Okay, one more thing that I wanted to show you. If we go back to contents, you can see within WS objects, there's a folder for each of our pibbles. And so if I double click on here and then double click on here, you can see our PowerBuilder source files. So each of these folders within the WS objects is going to contain our source. And then as we change different objects, we would see dated commits if we were to go to the history, and we would begin to get additional comments down here, and we could double click or actually single click on those comments, and then we get a little bit more detail. And you can see that what happened is for pretty much every object in the application, we can see what happened, and green indicates no changes, but if we had changes, they would be highlighted in red. And so that's one thing I wanted to tell you so that you're aware of that. So now let's go back to the slideshow. So give me a second. Okay, so because I want to make sure that the software is still recording, what I'm going to do is I'm going to open the slideshow, and then what I'm going to do is we'll start it up so that you have a better view. So let's talk about creating branches in PowerBuilder 2019 before release 3. There's quite a few steps, which leaves plenty of room for error. And so we're just going to walk through it real quick so that you can see everything you have to do. So first of all, close PowerBuilder, because some of these changes are going to affect PowerBuilder, and all of this is going to happen outside of PowerBuilder. This is a workaround, and we're going to be using Tortoise Git. So some of the pictures you see are going to be Tortoise Git in order to to perform this workaround for branch management. So the first thing you're going to want to do is stash your changes in the master branch using Tortoise Git. And what a stash does and how it's different from a commit is you may have uncommitted changes. Maybe you're not done. All stash is going to do is kind of save your changes off somewhere. You may not necessarily want to commit them yet, so that that's saved off to the side. So when we come back to this master branch that we're on right now, we can just pick up where we left off. Then what we're going to have to do is we're going to have to create a new branch, and we'll call it development within the repository. And so I, as an admin, would have to go to the repository and create that branch from within the repository. We're not going to do it here. As it turns out, if you can see down here, there is a create branch function that is in Tortoise Git, but that may not necessarily be everywhere. But best thing to do is to go and create that branch within your actual repository on the server. Then the next thing we're going to do is switch checkout. Okay, so we're going to choose this function here, and what that'll do is that will allow us to actually switch over to the development branch. And then what will happen is you can see over here where it says git commit master, that's going to change to development. So you can double click on the PBW file to start PowerBuilder, or rather just reopen the PowerBuilder IDE and open the workspace that you're going to be working on. And then the next thing you want to do is, once you do that, PowerBuilder is going to say, or it doesn't say it actually, you'll be on the development branch now because you've switched it outside of PowerBuilder. So make sure you click refresh, like I showed you earlier, to get all the objects from development into the IDE. That's an extra step you need to do. You can do your development in the IDE, and you can also use the git commit in the IDE or within PowerBuilder to commit to the development branch. When you're ready to submit your commits in development, you need to use Tortoise Git to push it to the server. So that's another thing you're going to have to remember is because you have to do all of this Git repo management outside of PowerBuilder when you're using branching, you need to do your commits and pushes outside of PowerBuilder. So what you do is you close the IDE, go back to Tortoise Git, do your commits, and then do a push. And you can see in the picture here that that's what you have to do. Number 8, you can switch back to the master branch using the same method mentioned above. You have to, once you've done your commit and push, switch back to the master branch. And then what you're going to have to do is once you do that, you use a stash pop if you need to apply the last stash. So that's going to bring that stuff back that we put off to the side earlier. Or you can use what's called a stash list or stash apply to restore the previous status of your master branch. So you may want to go get what your master branch looked like before you even did the stash. Then you can reopen PowerBuilder. You're back on the master branch. PowerBuilder won't tell you that, but you have to be aware of it here behind the scenes, and then do another refresh, because refresh is what brings that information, brings those objects that may be different from what you're doing in development back current in the PowerBuilder, so you can be working on your master branch again in the state that you left it in. Okay, so let's go back to our demo now, so I can show you some of the branch management capabilities that are in PowerBuilder 2019 Release 3. So here we've got our application that we downloaded, and if I open this up here, now you can see there are little circles that are next to our items that are in source control. And let's go back to the workspace and open this up. And you can see we're on the master branch, so that's new. That's awesome. We can see it in the IDE now. And then what we're going to do first is we're going to create a branch. So this is going to be a separate area where we can do work, development, that's separate from our primary source of code. So let's click that. And we can choose to do one of two things. We can choose to create this branch and seed it with code from our master branch, or we can put branches off of branches. So we may create a development branch, and then we may create a branch using development code to develop individual features. And so that allows us to have several levels of redundance, and then just merge code level by level as we complete things and things get tested. So we're just going to use the code in the master branch, and we'll call this branch name development. Okay, and then I'm going to say okay. Okay, so what we've just done is we've created this branch on our local repository. It's not up on the server yet. We just created it in our local repository. Okay, now we're not in that branch yet. We just created it. So you can see we're still in the master branch. And now what we're going to do is let's switch to that branch. Okay, so we'll click Git Switch, and then we'll pick the one we want to switch to. And you can see the master branch here is our local master branch. And then origin master is our server repository. So we can go and switch to that and do some things. But for this demo, let's switch to development. So we'll say okay. And then another cool thing here is when we switch to the development branch, it does the refresh for us. So that was an extra step, which, you know, there's so many steps in the workaround. There's many ways you could make mistakes. And so what's awesome about what they've done in release 3 is that it does these things for you. So now what I'll do is I'll right click on here, and you can see now we're in the development branch. So let's do something interesting here. So what I'm going to do is I'm going to open up this pibble, and then I'm going to open up this window. Okay. Okay, and then what I want to do is let's change the color or something like that, so that, you know, something that we can see. So let me go over here. I'll change it to red. Okay, there we go. And this is called WMSI construction, or CONSTR. So let's remember that. It's top of the customer pibble. I'm going to save it. And then the best thing for me to, and then let's close that. Okay, and then the best thing for me to do is, before I go working on another branch, let's get this done and let's get this committed, because if you leave uncommitted changes before you go to another branch, it'll actually carry this over into whatever branch you switch to, and you probably don't want that. So when you're working with your local repository, in order to, you can be saving things, you can be committing things to your local repository, because you're not going to impact the pristine code that's up on the server. This is your local repository. And so let's just right click on this, and then we're going to do a commit. And then we'll say test. It's good to add comments, and I think I've even made them required here. Test commit development. So we know. So we'll say development branch. So let's say OK. Okay, so now we've committed those changes, and we know it's this object, and we know that, let's open this object again. Okay, and you can see it's red. Okay, so let's close it. And now what I'm going to do is, let's go back to the workspace, and I'm going to, okay, I'm not on the workspace, let me go up one. On here it's doing the refresh for us, and it's actually bringing back the version of that WMSI construction that's in the master branch. So let's open it up now that we're back on the master branch. And see, you can see we've got the other version of this window here. Okay, and now what I'm going to do is, you can see we're in the master branch. Let's just switch back to the development branch again. Say OK. And we have to wait for it to do its thing, do its refresh. Then let's open it up. And now you can see we've got our other version here. So the next thing we want to do is, let's go back and look at our repository. So I'm just going to click on repo here so that we can go back up a couple of levels. And then let's go to branches, so we can, in this particular, in Azure Dev Ops, you can see your branches here. And you can see that all we have up here is the master branch right now. Okay, so let's go back to PowerBuilder, and we're in the development branch here. So now let's do a git push, so that we can push our stuff actually up to the server repository. So I'll go back in here. We'll do a refresh, and there you go. Look, it says development just now. So now we've created the development branch up on the server, and we can work on our local repo and development. We can push those changes up to the development branch on the server. We can be working in our master branch locally, and then we can ultimately push those changes up to the master branch on the server. And see, that's really cool, and it's very powerful. Let me go back here. Okay, now what I'm going to do is we'll minimize this, and then give me a second. Okay, so one of the last things I want to talk about is the case study. So what happened is the developer had pushed an object that wasn't quite ready for prime time up to the repository on the server, which now is going to affect all your other developers if they ever need to pull stuff down. I mean, maybe a developer pushed an object that needed to go to the server, and when the other developers do a pull, they're going to get a good object and that bad one, and that'll cause problems. So what this developer did is he created a new local repository. Then it gave him a new repository URL, so he executed a git clone, pulling down from the repository. Then he did a git log, which lists all the commits that have been done to the repository. And then he did a git reset hard, and then whatever hash he needed to use. And what a hash is it's just an identifier next to each commit that's gone on. So he just basically grabbed the commit that was right before the one that didn't need to happen, and then he did a good git push, and it basically reset the repository back to, or rather the repository up on the server back to the status that it was in, or the state it was in before that bad commit was done. And so, you know, you're welcome to experiment with this and see what happens. Now, one final thing that I wanted to show you, I'm going to go back up to the demo machine, is there's another function in here called upload pibble. And you're going to use the upload pibble function whenever you add a new pibble to your application. There are other things that can happen. Sometimes there might be structural changes. You might delete objects out. You might move objects from one pibble to another. And whenever you do things like that, you will need to re-upload. So you hit upload pibble and then you commit it and push it like anything else in order to tell your repo about those structural changes. So any pibble that was affected, you're just going to need to upload that again, because otherwise they can go stale and you could end up having problems. And then that is the end of my presentation. I hope that you enjoyed it. And now what I'm going to do is sign off. Thank you, thank you, thank you.